Alright, congratulations, you made it through section P. Now, for all that, it's time for chapter 1, graphs of equations. Alright, so we're going to learn about intercept, symmetry, just some basic forms of some graphs that we're going to be working with all year. Alright, remember, take your notes, rewatch the confusing parts as many times as you need, and write down questions. Alright, so what is an equation? An equation is just a relationship between two quantities. So right there in that first example, I have an equation, y equals 2x minus 3. And that's the set of all points. So a point, x comma y, ordered pair, is where y is a dependent variable. In this case, is 3 less than double the x value, the independent variable. So independent means you could plug in whatever you want for x, and then y depends on that. So that equation is y in terms of x. A solution is one of the infinite amount of points that satisfies the equation. So one that makes it true. And when you take all the solutions and plot them on an xy axis, then that is called the graph. So throughout the year we're going to learn a couple different ways to graph different types of equations, but the one that you need to know for every single graph is just plotting points, making a table of values, so making up values for x, arbitrary random values for x, plugging them in, seeing what the y values are, and then plotting them. And the more dots you make, then the more accurate of a graph you'll have. So let's just work on that. Now, here are the first two, just a simple y equals x and y equals x squared. Now, if I were to ask you to do this with a table of values, I would expect you to do it without a calculator, where you just make a t-chart like this. And here's y, here's x. So if y equals x, when x is 1, y is 1. When x is 2, y is 2. When x is 70, y is 70. Alright, and then plot those points, and then connect them. And you got your graph. Alright, pretty primitive way of graphing. So I want to show you how to do that on a graphing calculator, how to make a table of values and also a graph. So if we open up our TI Inspires, alright, so you gotta go to the home screen, make a new document, and add a graph. Then up here we're going to type in the first graph that we want to do, which would be x. Y equals x. Now it says f1 of x, so that just means it's in function notation, but f of x is the same thing as y, and we'll learn about that in chapter 2. And the 1 just means it's one of the 99 you can graph on this xy axis. Alright, and there's your graph. So it's a line with slope 1, y-intercept 0. Now, to find the table of values. To find the table of values, we're going to go to Menu, and it's the 7th option, so you hit 7 or click on Table, and then click on Split Screen Table. And you see it comes out on the right, and you can use your cursor to kind of go between, different values of x and y. So like when x is negative 4, y is 4. When x is negative 3, y is negative 3. Alright, now this column is x, and this f of 1 column is going to be y. Alright, pretty straightforward. You get rid of the table by going to Menu, and then Table, and then Remove Table. Alright, and so that's the first graph that we got. The next one is going to be y equals x squared. So you can hit Tab, and you can either graph it over this graph, or just hit up, and then edit y equals x, or f of x equals x, and put the little square there, hit enter, and now we got our graph. Alright, and then we'll check out our table of values. So if you didn't have the graph, you can make this table of values yourself, like plug in negative 2 and get 4, and then you plot this point right here, and then, it'd be right there rather, whatever, let me erase that. And then do negative 1 comma 1, then plug in 0 0, and then 1 comma 1, and then 2 comma 4, and you connect the dots and you see you got a parabola. Alright, So a couple things I want to point out. This parabola is increasing from the origin to the right and decreasing from negative infinity to 0. It's got an x-intercept at the origin, so that's where it crosses the x-axis, right at 0, 0, and also a y-intercept at the origin. And it's got a minimum value right here. Alright, so that's called the vertex of the parabola, and you can actually find that with the calculator as well. If you go, let's get rid of this table for a second. You go menu, table, remove table, and then go back to menu. We can analyze the graph, and we can find out where the minimum value is. So now your calculator is asking for a lower bound, so you got to find an interval where you think the minimum is occurring. So we're going to click, alright, lower bound means to the left of the minimum, upper bound means to the right of it, and then we got our point right there, 0, 0. Alright, that'd be a minimum value. And also, if you didn't know that's where it crossed the x-axis, then you could go back to analyze graph and do 0. And then it would tell you that that's a 0 as well, 0, 0. Alright, and let's just, using this function again, if we go back, if we hit tab, we can hit escape to get rid of these windows, hit tab, and let's change our graph so that, move down 1. Now, it has a 0 right there, the minimum is still there, and to find the other 0, we'd go menu, analyze graph, 0, and there you go. So you can find out all this good information from the graph just by using your calculator. Alright, let's look at other types of graphs now. So from this, you should know that y equals x is just going to look like a straight line. Y equals x squared is going to look like a parabola. Alright. Now the square root of x and this equation right here, x squared plus y squared equals 9. Let's graph those on our calculator. So the square root function is going to look like a sideways parabola. So we're going to go back to our graph window, hit tab, hit up, and we're going to erase this equation and type in the square root button, which is right above x squared. So you can do control x squared, alright, and then just type in x and then hit enter. And you can also find the square root button with this button right here. It's next to the 9, alright. It's got all your functions on it. If I just were to click on it, you would see all the things you could do there. So whenever you're having trouble finding a function, you can use that button. Alright, and when you want it to go away, just hit escape. Alright, so now we still have, so I want to get rid of this minimum thing. So you could highlight it and I think hit delete. Highlight this with your cursor, hit delete. I mean, we could have just made a new graph as well. Let's go to this point. Alright, so that is what a square root function looks like, and like I mentioned earlier, it has a half of a parabola, but facing the other way. Alright, now when we learn about functions and we learn about the vertical line test, we'll understand why it's not a full why it's not a full parabola to the side. It's just a half a parabola. But if you wanted to construct this graph, you can make a table of values. So see what that would look like. We'll do menu, table, split screen, and you see, right, when you plug in 1 in for x, or when you plug in 0 in for x, you get 0. Plug in 1 in for x, you get 1. Plug in 2. Probably wouldn't do that without a calculator because you get the square root of 2, which as a decimal looks like that. If you had to graph these, I would plug in x values that were perfect squares. So when you plug in 4, you get 2. When you plug in 9, you get 3. Alright, and when you connect the dots, it's going to look like this graph over on the left. Notice how when you plug in these negative numbers, you're going to get errors because those are not real numbers. We'll learn how to take the square root of negative numbers later in this chapter. But for now, just know that it's not a real number, so it's not going to appear on your real number XY axis coordinate plane. Alright, so from this, you should just know that a square root function is going to look like that. Alright, it's going to look like half a parabola sideways, just like that. Alright, and we're going to learn to shift it around as we go as well. Alright, so let's graph a circle now. So how do you do that? So we're going to first hit tab, and then hit up, and erase this graph. So we'll start fresh. And if you notice, if you hit tab again, it's going to let you plug in a function. But a circle is not a function, and we'll learn why one day. But it's not a function, it's an equation, and they're different. So if you want to graph something that's not a function, you're going to have to hit menu and change your graph entry, because the calculator is set on default to only graph functions. But if you want to graph equations like lines, parabolas, circles, then in this case circle, we're going to choose circle and then 1, because the circle that we were given in this example right here was in center radius form, and we'll learn that later in this video. But that means just by looking at it, you could see what the center is and what the radius is. So we're going to plug it in, so it's x squared, so we'll do x minus 0 squared, and then y minus 0 squared equals 3 squared. And then we graph it, and there is our circle. Alright, so if you were to just plug in various values for x and solve for y and graph them, this is what the circle, this is what your equation would look like. And you would make a table of values by hand, but if you wanted the calculator for help, you'd go menu table. Alright, I guess you can't do a table for it's not a function. Alright, but for example, if you plugged in, say, 0 for x, alright, if you plugged in 0 for x, you'd get 0 squared plus y squared is equal to 3 squared, which is 9. Alright, so that cancels out, and then you get y squared is equal to 9. Solve for y, take the square root, and you get y could be plus or minus 3. So when x is 0, you get y could be 3, or when x is 0, you get y is negative 3. Alright, and you could, plug in 2 in for x, and you'd get decimals for y, but you'd, still get 2 points. If you plugged in 2 in for x, you get a y value here and a y value there. Alright, and if you kept plotting these points, it would make the circle. So you make a circle graph just like any other graph until we learn how to transform it, and that is by plugging in points for x, solving for y, and plotting them. Alright, 2 other ones. We got y equals x cubed. Alright, so then also the absolute value of y. I'm sorry, y is equal to the absolute value of x. So let's graph them. So we'll go back to our calculator. Let's just go home, new document, and we're going to say no, and we're going to add a graph. Alright, so we wanted to graph y is equal to x cubed, so we're going to hit x, and then the cube button to do that, we're going to hit this caret next to x squared, and then plug in a 3 there. And if we look now, it is constantly increasing, meaning when you look at this function, as the x values approach infinity, the y values are approaching infinity, as opposed to the parabola, which was decreasing at first as x was approaching 0, and then increasing as x was approaching infinity. So that's because these are different functions. One's x cubed, meaning when you plug in, say, a negative number, the number is going to stay negative. For x squared, though, when you plug in a negative number, the y value is going to become positive if you have y equals x squared. So that's one main reason why these functions look different, but they're similar. The y equals x squared and this y equals x cubed, they both have y and x intercepts at the origin. Alright, and we could find that by doing menu, analyze graph. We could find the 0 by putting the lower bound to the left of and the upper bound to the right of where we think the 0 is. Alright, but if we wanted to find a minimum it wouldn't work out as well. It would just find the smallest value on this interval. So if we did minimum from, lower bound to upper bound, it's just going to give us the point all the way to the left. Something interesting to point out. I think this kind of looks like a quadratic that got bent down. So like you had a parabola like this, then you took this part and then bent it down. So that's kind of what this x cubed graph looks like. All right. And then the other one was the absolute value of x. So if we wanted to graph that, we could go to menu, and I don't know why I hit menu actually. I didn't need to, so we're going to hit escape. We're going to hit tab actually, and then hit up, and find the absolute value button. We're going to go to the button to the right of the 9, and hit absolute value, and then type in an x. We see it kind of looks like a parabola. They both have minimums at 0, 0, but it's more straight. It doesn't have that curve to it. So if we look at the table of values, we'll see why. The absolute value function just takes the x value, so you plug in -3, and you get that distance that the number is from the origin. So you get 3. Plug in -2, get 2. It's just going to turn the number positive. -1, 1, 0, 0, 1, 1. If you plot all these points, you're going to get that V shape that this graph has. All right? Just like a parabola, it has a 0 x-intercept and a minimum at this point right here, 0, 0. All right. The last one, 1 over x. So let's just go home, new document, not save our changes, and add a new graph. And we're going to do 1 divided by x. All right, and this graph has a lot of crazy stuff going on. It doesn't have an x-intercept or a y-intercept. It never crosses the x or the y-axis because it has something called asymptotes. So it's a rational function. All right, we learned about that a little bit in P5. All right, it's never going to cross x equals 0 because 0 is not in the domain. Also, it's never going to cross the x-axis, y equals 0, because no matter how big or small x is, as long as it's not 0, y will never equal 0. Think if x was really big, as we went all the way down this x-axis here to like 1,000, all right, what would the y value be? Well, it would be 1 over 1,000, which is pretty close to 0, 1/1000th, but not quite. And as x got bigger, y would just get closer and closer to 0, but never actually touch it, because 1 will never be 0, and you're just dividing 1 more and more ways. Doesn't mean you'll ever hit 0. You'll just get very close to it. All right, and we know that it doesn't hit the y-axis because, again, it has an asymptote there, vertical asymptote. X equals 0 is not in the domain. You cannot divide by 0. All right, so whenever you see, a graph like this, y equals 1 over x, they're all going to have the same kind of shape to it. 2 curves with asymptotes at the x and y axes. All right. Let's get back to it. So good calculator practice there. Now let's just learn how to find x and y intercepts without the graphing calculator. So to find an x-intercept, we're just going to plug in 0 for y. And that's because every point on the x-axis, say like this point, 0, 0, or this point, 5, 0, or this point, -11, 0. They all have something in common. And the thing they have in common is that y is always equal to 0. Alright, so that's why you simply plug in 0. You try to see when is y going to be 0, and that is the x-intercept. Alright, and for the same reason, when you want to find a y-intercept, because every point in the y-axis has an x-coordinate of 0, like this point, 0, 2, or this point, 0, comma, negative 3. Whenever you want to find a y-intercept, you just plug in 0 for x. So let's practice that real quick. So first, in this example down here, find the x-intercept. We're going to plug in 0 for y. Alright, so you get y is equal to x minus 5 squared. Plug in 0 for y, you get 0 is equal to x minus 5 squared. Alright, now, if we try to solve for x, we could take the square root of both sides, and you get 0 is equal to x minus 5. Add 5, and you get x is 5. So we know that on this graph, there's a point right there, and that's what's going to cross the x-axis. To find the y-intercept, we're going to plug in 0 for x. So you get y is equal to 0 minus 5 squared. Alright, that we can evaluate. 0 minus 5 is negative 5. If you square it, negative 5 times negative 5, since the square, the negative 5 is in parentheses and you're squaring it, it's going to become a positive 25. Alright, so you get this point all the way up here at 25. Then we know this graph is going to look like a parabola, and if you plot a couple more points, like let's say you plugged in 6 for x, you'd get 6 minus 1, or 6 minus 5 is 1 squared is 1, you'd get this point right here, 6 comma 1. And we would see, alright, start to get a feel for the graph. It's going to look, and we know it's x is being squared, so it's going to look like a parabola. So that's just kind of how you can use the x and y intercepts and maybe one or two other points to see what the graph will look like. Alright, let's try one more. Find the x and y intercepts, and that's with this circle here. So find the x and y intercepts of this equation. So we're going to plug in 0 for x first to find the y-intercepts. So when you plug in 0 for x, you get 0 minus 3 squared plus y plus 5 squared. So that's going to become a 9 right here, because that's 0 minus 3 is negative 3 squared is 9, plus y plus 5 squared is equal to 4. And then you subtract 9, and you get y plus 5 squared is equal to negative 5. Now you have something being squared here is equal to a negative number, which is impossible. You can never square a real number and get a positive number, or and get a negative number. You'll always get a positive number or 0. So there's no solution here. And if you tried to find it, if you took the square root of both sides, you'd get y plus 5 is equal to plus or minus the absolute value, the square root of negative 5, which is not a real number. Right? We'll learn later that that's equal to 5i, but that still cannot be graphed on an x and y axis. So there's not going to be a y-intercept. So when asked for the y-intercepts of this equation, there are none. And I'll explain how that's possible in a second. If we plug in 0 for y, the same thing is going to happen. Or maybe not. Let's see. So you get x minus 3 squared plus, plug in 0 for, the same thing is going to happen. Plug in 0 for y squared, and then you get, alright, that's 25 equals 4. X minus 3 squared plus 25 equals 4. When you subtract 25, you're going to get a negative 21 over here. So this graph has no x and y intercepts. How is that possible? Well, it's a circle, right? And it's a circle with radius 2 centered at 3, 5. So it's going to look something like this, where it never hits the x or y axis. Alright, and if you don't believe me, I know you do, but let's just graph it on our calculators real quick. So you go here, you're going to go home, new document, go and save that, and then we're going to go graph, menu, graph entry edit, and then equation, circle, and if we type that in, so we're going to do a minus negative 5 here, because it's in that form. So if you want to add 5, you have to do minus negative 5. Then equals 2 squared. I messed up, but you get the idea. I should have shifted it to the right and down, not to the right and up. But you can see it's never going to cross the x and y axis. So for certain equations that aren't functions, it's very likely, or it's sometimes likely, to not have an x or y intercept. Alright? Now, before we talk about even and odd, I'm going to cut this video short and then do a whole nother video on even and odd functions. Alright? So thanks for watching.